Good evening, friends. Today we will discuss about the related calculation in traction distribution system in OHE and in substation. So better to start from where we are taking the power supply. This is the first stage. So first we'll see the source impedance. Mainly we are taking 132 kV two phase for our power transformers, single phase power transformer. The grid 132 kV faultable as per the guideline is around 5000 MVA. So easily we can find out the source impedance. Why do we need the source impedance? As because when any busbar fault will be created in the TSS or busbar post will start punctured, then an earth fault will occur where the minimum impedance will act. Impedance minimum means maximum amount of fault current. Because OG impedance, local impedance, everything is not coming here. So the maximum fault current will occur when a busbar will face an earth fault. So to find out this, only two impedances will be there. One is source impedance. That's mean in 132 kV side from the source the impedance is acting, because our 132 kV circuit will compete up to the grid outgoing side, transformer output side in the grid. So we have to calculate the source impedance. It will be added during earth fault of the 27 kV bus. The maximum fault current will occur when only the source impedance and transformer impedance will be there. OHE impedance will not be there because the earth fault is in the traction substation and the fault current will bypass the OHE and locomotive, because our rule is current will flow the shortest route of low impedance. So they will not go for the higher impedance. So they will straightly busbar to earth and earth to the transformer earth length. The current will flow and it will be maximum fault current. So why we need this fault current, we have set the HV side instantaneous overcurrent setting 25% more of the maximum fault current in the 27 kV side. Means any earth fault in 27 kV side will not treat the OCR 1 because it is set 25% above. So first we have to find out the maximum fault current in the 27 kV side, because we have to set the relays like OCR 2, OCR 3, then wrong phase coupling, distance protection, delta I. So these things are required. Now generally the power transformer is having 12% percentage impedance. 12% percentage impedance. For a 21.6 MVA power transformer, you can easily find out the impedance per phase. That is not phase here, transformer impedance. Transformer impedance, and source impedance will be per phase. There are two phases, so it will be multiplied by 2 for the source impedance, but for power transfer impedance, it will be the total impedance of the power transformer. It is 12%. So what we will do, we will find out the impedance, total impedance means when the power transformer will take the full load current and the circuit is complete, then the whole capacity of the transformer will be utilized, and at that time the percentage impedance will be 12%. So it is, we know kV square by MVA is the impedance. We have already seen kV square by MVA is equal to impedance. Our voltage is 27, so 27 square, and power transfer impedance is 21.6 MVA, and its 12% is the transformer impedance. Its 12% is the transformer impedance. This is the transformer impedance. Now, for source impedance, what we have done, the fault level is 5000 MVA. Fault level is 5000 MVA of the taken from the grid. Generally, it is 5000 as per the guideline. So it is also kV square by MVA. So it will give the source impedance in the 132 kV side. Convert it into the 27 kV side. So it will be multiplied by 27 square divided by 132 squares. Then it will be converted in the 27 kV side. It is near about 0.1458. Now when the bus will connect to an earth, then this two impedance will only be there, and the amount of current we can find out. Here we have seen that when we have created bus bar and bus earth fault, the maximum fault current is how much? 27 kV. At that time, suppose the voltage is 27 kV divided by transfer impedance plus source impedance. And as per the RDSS guideline, it is coming around 6400 ampere. 6400 ampere. How to find it out? 27 kV divided by the two impedances. What? Transfer impedance plus source impedance. Source impedance is multiplied by 2 because earth fault in the secondary 27 kV side equal to face-to-face fault in the primary, because no phase is earth in the secondary, then it will be short circuit. So face-to-face fault in the, so per phase, this impedance is per phase. So for two phase it will be multiplied by 2. It will be multiplied by 2. So it is coming around 6400 ampere, and this 6400 ampere will utilize for various relay, mainly OCR, OCR1, OCR2 and OCR3. For OCR1, we will keep the current, fault current, how much? 25% above. The instantaneous relay will be set to 6400. It will be converted into the 132 kV side. It will reduce. So it multiply it 27 by 132. Then it will reflect the current in the primary. Then 25% more means multiply 1.25. That will be the current setting of the relay OCR1. That will be the current setting of the relay OCR1. And percentage you can find it out easily. Our rated current is 5 ampere, so how many percentage it will be, you can find it out. Already I have shown in the previous videos, so you can easily find it out. So step by step I will load this calculation. Today I am busy, will try to upload another calculation in the night. So today, good evening friends. Okay.